All right, we're back for a second video for 6.4 confidence intervals for variance and standard deviation. We have a few notes that we're going to go through and two examples. So let's get started. So let me share my notes with you. And they look something like this. So for our intervals, we have two formulas. It depends whether they ask for the variance confidence interval or the standard deviation confidence interval. Most of the time, they'll probably just ask for both. If you want to find the confidence interval for variance, remember variance is sigma squared. There is this formula that is n minus 1 times s squared, so the standard deviation squared, or just sample variance, divided by the right-hand chi-squared value. And on the other side, we have n minus 1 times the sample variance, or standard deviation squared, over the left-handed chi-square value, right? If they ask for a variance interval, the sigma squared will be in the middle. In order to get to standard deviation, or just sigma, that interval is the exact same formula, except for it's the square root. Because remember, when we talk about variance in standard deviation is the square root of variance, or variance is the square of standard deviation. So if you take your answer from the variance interval, that will, and square root it, that will give you the standard deviation interval. Right, so steps for going through this process. Let me put all of the steps up here for you. Right, the first step, you have to verify that the population has a normal distribution. If it doesn't have a normal distribution, we can't do it this way. Second step, identify the n value and the degree of freedom, which remember is just n minus 1. We're going to use those values not only for the formula, but to find the chi-squared values for the left and right-hand endpoints. Step number 3, we're going to find the point estimate s squared. So we need to find that variance squared. And they can either in the problem give you variance, just give you the s squared. They can give you standard deviation, so that when you plug it into the formula, you have to square it. Or they could just give us a data set and ask us to find the standard deviation or variance, which remember, if you have to do that, that's just in the TI-84, that 1-bar stats after you have your list. But most of the problems we're going to encounter, they're just going to either give you standard deviation or variance. Now, that being said, it is important that you recognize which one you're getting. If they give you variance, you just plug it into the formula and you're done, because variance is s squared for the sample. If they give you standard deviation, when you put it into the formula, you'll still have to square it, because sample standard deviation is just s, and the formula has an s squared. So it is important in the wording, and make sure you label them correctly when you're going through the examples and problems. The next step, we're going to go through what we were practicing yesterday, finding the critical values, the chi-squared r and the chi-squared l, the left and right hand endpoints. They're going to be corresponding to the confidence level, and you're going to use table 6, the chi-square distribution, which is on page A19 in our book. Then we're going to find the left and right hand endpoints for the population variance interval. That's just using the formula that we talked about above. And then take the square roots of that to get the endpoints of the population standard deviation interval, which once again is in the formula that we talked about above. So those are the 6 steps we're going to go through to find both the population variance and standard deviation confidence intervals given a certain level of confidence. So we have 2 examples. The first one I'll walk through with you. So this is the first one. It says, find the 95% confidence interval for the variance and standard deviation of the nicotine content of cigarettes manufactured if a sample of 20 cigarettes has a standard deviation of 1.6. So I like to go through and just identify what I have, right? I'm given this 95% confidence level. My sample size was 20. If my sample size is 20, that means my degree of freedom is 19. The standard deviation was 1.6. So this is where it comes in important, the notation that you write. If it says it has a sample standard deviation of 1.6, that's only S. If it told you the sample variance was 1.6, then you would be writing S squared, which matters when you put it into the formula. If it's variance, you just plug it in, If it's standard deviation like this one, you'll have to square it to get to that S squared value. I'll find my left and right hand critical values. Remember, in order to do that, I take 1 plus or minus the C divided by 2. So for the left endpoint, if I do that, I get 0.975, the right endpoint 0.025. And then these are the values with my confidence level that I look up in the chart to get these critical left and right hand values. So now I have everything I need. For the formula, I need an N, an S or an S squared, and my 2 critical values. So I put them into the variance formula, and I got 1.48 to 5.46. That's most of the work. To get to that last step, the standard deviation, all I have to do is take the square root of my 2 endpoints, 1.48 and 5.46, and that will give me the standard deviation interval, which is 1.22 to 2.34. So that's the whole process, right? Yesterday we were just practicing finding these critical values. Now we're actually plugging them into the formulas to get the variance and standard deviation intervals. All right, let's look at a second example. So the second example I want you to try on your own. It says we have a 90% confidence interval for find the 90% confidence interval for the variance and standard deviation for the lifetimes of inexpensive wristwatches if a sample of 24 watches has a standard deviation of 4.8. So very similar to the last problem, they gave us a confidence level, they gave us an N value, they gave us a standard deviation. We got to go through and solve it. So take a second here, try to go through and solve this, and when you're ready, start the video back up. All right, now that you solved it, let's go through and see what our work has here. So once again, I found the degree of freedom being n-1, 23. I just wrote S because they gave the standard deviation is 4.8. I went through the same process, found the left and right hand endpoints, added and subtracted the confidence to 1 divided by 2, looked them up on the chart, and then plugged them into my formula. Once again, because they gave me standard deviation, when I plug it in, I have to square it. If I simplify that down, my variance interval is from 15.07 to 40.48. And if I take the square root of both of those numbers, I get down to 3.88 to 6.36. So that is all we have for today. We're celebrating lax season, of course, a season that never happened, but would have been a good one. So hopefully you like, subscribe, and comment on the video, and we'll be back for another topic.